First of all, we will apply shifting on our input signal. Now, the process of shifting in this signal, we'll name it U of n, and it is being shifted by x is equal to n plus 3. U of n is equal to 1 2 minus 1 2 0 1 1 3. This is the shifted version, where this the zeroth position is now has become incremented. It has been incremented with 3. It has this position lies on now minus 3. This is the minus 2 position, minus 1, and this is now the 0th position. If we draw the signal over here, the signal will look like something. 0. On the 0th position we have 1, 1, and on the second position we have 3. On the other hand side we have 0 at minus 1, 2 at minus 2, minus 1 at 3, 2 at minus 4, 1 at minus 5. Now this is our signal U of n. This is the resultant signal representation. Now we will apply flipping. As we know that we will have to make a mirror image, so we just make a mirror image. 1 2 3 4 and 5, 1 and 2. This will become minus 3 plus 3 amplitude. This is 1. At the 0th position is 1. This will move to the other side. 1 we have 0, 2 we have 2, 3 we have 1, 4 we have 2 again, and at 5 we have 1 again. We'll name this signal as W of n, and this is equal to 3 1 1 0 2 minus 1 2 and 1 easily. Now the last factor that we will apply is scaling operation. Now the scaling, the expression for W of n is equal to minus n of plus 3 x. Now scaling is done by the factor of 2 units. Now for y is equal to, the resultant we'll say it y of n. Result will be 3 1 2 0 at the 0th position, and excuse me, not 2 0, this will be the resultant signal, because everything else at the odd places will be neglected because of the property of compression. So the resultant signal that we will have would look something like this. At 2 we will have 3, 1 will be neglected because it will change into 1 over 2. Y of n for 2, y of n for 1 will be equal to it will become 1 over 2, 1 over 2, and there is no for x, and there is no point at 1 over 2 which is equal to 0, so this will be neglected, and then 1 at the 0th position, this is the 0th position, and then 2 at the 2nd position, 3rd will be neglected, and 2 at the 4th position. This is our resultant signal y of n. Now we will discuss about the impulse response of a system. As in the previous lecture, I have told you that the most important signal on which the whole basis of DSP has been laid is the unit impulse signal, which is 1 for n is equal to 0 and 0 otherwise. This looks like something this. It has 0, 1 at the 0th position, it has 1, and all the other places up to infinity are 0. So what is the impulse response of a system? Impulse response of a system is the response of the system when it is the response of a system when a unit impulse signal is fed to it. So when we apply a unit impulse on a system, the resultant, which this is unit impulse, and we provide it on the input side of a system, the result we will obtain is the unit impulse response, the impulse response of that particular system. Now we will share an example. Now in this example, we'll consider this system that I have listed below. This system, we will find its impulse response. For this, the input has to be the impulse signal, which we have defined above. Now I will just put and calculate the results for each of the numbers, each of the points in the time domain. For y is equal to, we know this impulse function is 1 at n is equal to 0 and 0 otherwise. So any other number on the time domain, any other coordinate on the time domain is 0, except for when it is 0, then its amplitude will be 1. So for n is equal to 0, we have what? This x of 0 minus 2x, and here we have 0, so plus x of 2. Here it is minus 1. So this is equal to 1. The rest of them are 0. For y is equal to minus 1, we have x is equal to minus 1, minus 2, x is equal to minus 2, this will become minus 2, plus x is equal to 1. So this will result in 0. For n is equal to 1, we will have x is equal to 1 minus 2, x is equal to 0, plus we will have x is equal to, and this we will have 3. Now this is equal to minus 2, because this is equal to 1, and when 2 minus 2 multiplied by this, we will have these are zeros, these will result in zeros, this is 1, both multiply we get minus 2. Now for y is equal to minus 2, y is equal to 2, we will have x is equal to 2 minus 2, x is equal to 2 minus 1 1, sorry, minus 3 for minus 2. If we have minus 2, they will both get summed up, and plus minus 2, and this we will have x is equal to 0. This will result in 1, other will result in 0, so we will have 1 as the amplitude for minus 2 point in the time domain. Now the next will be x is equal to, this is also minus 2, and this is 2 minus 2 x, this is equal to 1, and this will be equal to x is equal to 4. This will result in, as there is no 0, so this, the result will be 0, so the signal will be somewhat like, now the result will be something like the solution set that we have uh, gotten by solving the problem, which is for 0 in the time domain we have 1, magnitude of amplitude of 1, and for minus 1 we have 0, and for minus 2 we have 1, and for 1 we have 0, and for 2 we have also 0. So this will be 1 0 1 for the 0th position, and 0 0. This is our resultant impulse response of the system. Now we'll consider another system, but this time the y of n variable, the y of n, the output function, is also considered and summed up with the input function. Now we have input function, as it is the impulse response, it is equal to the impulse signal, and the y of n, the output signal that we have, will be considered h of n, as it is the impulse response of the system. So when we solve it, we will get something like this: h of 0, this will have 0.5, and as n will be equal to 0, h of 0 minus 1, and we will consider it with no initial conditions in the relax mode, no initial conditions applied, in relaxation state. So what we will get, 0.5 minus 1 plus x of 0, which will be equal to 1, that is 1, For h of 1 we will have, if we solve it, then 0.5, and this will cut out and become h of 0. This will become of 1. This will result in 0, and this will result in 0.5 multiplied by 1, which we will have 0.5. For h of 2, this will result in 0.5 multiplied by h of 1, which will get the value from over here, plus x of 2, which will be equal to 0. This will become 0.5 multiplied by 0.5, 0.25. For h of 3, if you calculate, we will get 0.2 0.125, and this, as this is a this will become close, this will reach infinity. So this is a perpetuating system. So thank you for tuning in. This was the last example, and see you guys next time in the next lecture.